Hey, welcome to your first real step into the world of programming. If you've ever wanted to build something with code but weren't sure where to start, you are in exactly the right place. Today, we're going to dive into Python, a language that's famous for being super powerful but also incredibly easy to learn. Let's kick off this journey and get you from zero to writing your very first program.
So here's our game plan. First, we'll cover the absolute essentials, Python's core building blocks. Then, we'll get into the fun stuff, making our code actually think for itself. After that, we'll see how to keep our code and data nice and tidy. We'll pull it all together by building a real working grading system. And finally, we'll chat about what comes next on your programming journey. Sound good? Let's do it.
All right, first up, the building blocks. You gotta learn the alphabet before you can write a sentence, right? It's the same idea here. Before we build anything cool, we need to get a handle on these simple foundational pieces. Don't worry, we'll take it one simple step at a time.
So what's the big deal with Python? Why is it such a great first language? Well, it all comes down to how simple and readable it is. A lot of other languages are cluttered with brackets and semicolons, but Python, it just uses indentation, spaces. This makes the code look super clean, almost like you're reading plain English, which is a massive help when you're just starting out.
Every programmer's journey starts right here with Hello World. And in Python, this is all it takes. The print command is basically you telling the computer, hey, display this on this screen for me. Whatever you stick inside those parentheses and quotes gets shown. It's really that simple. And just like that, you've written your first real piece of code.
Okay, let's make our programs a little more interesting, a little more interactive. The input function does exactly what it sounds like. It gets information from the user. It literally pauses the program and waits for you to type something in. And whatever you type gets stored in something called a variable. Just think of a variable as a labeled box. Here, we've labeled our box name, and we're putting the user's input right inside it. Data comes in all different shapes and sizes, and Python needs to know what kind of data it's dealing with. For whole numbers, we have int, which stands for integer. For decimal numbers, we use float. For any kind of text, we use string or string. And for simple true or false values, we have bool. Getting these down is really important because it tells you what you can and can't do with the data. You can add two numbers, but you can't really add your name to your age, right? Awesome. We've got the basics of storing and showing data. Now, let's kick it up a notch and teach our code how to actually think and make decisions. This right here is how programming starts to feel like a superpower. To make our code think, we need some tools called operators. You've got your arithmetic operators for all the basic math stuff, adding, subtracting, you name it. Then you have comparison operators, which let you ask questions like, hey, is this number bigger than that one? And finally, logical operators, like and, let you check if multiple things are true at the same time. This is how we give our code a brain. The if-elif-else structure is like a fork in the road. The code gets to the if and asks a question. If the answer is yes, it goes down that path, does its thing, and moves on. If the answer is no, it goes to the next question, the elif. It keeps going until it finds a path that's true. And if nothing is true, it just takes the else path as a default. Simple as that. One of the best things about computers is that they don't get bored doing the same thing over and over. That's where loops come in. A for loop is your best friend when you know exactly how many times you need to do something. A while loop, on the other hand, is for when you just want to keep doing something as long as a certain condition is still true. Both are huge time savers. You're doing great. Now that our code can think and repeat itself, let's talk about organization, because as your programs get bigger, things can get messy fast. In this section, we're going to learn how to structure our data and code to keep everything clean, efficient, and easy to read. So what do you do when you have a bunch of related items? You group them together. A list is like your grocery list. It's ordered, and you can add or remove things. A tuple is more like a set of GPS coordinates. Once you set them, they're locked in. And a dictionary is just like a real dictionary. You have a key, which is the word, and a value, which is the definition. Each one has its own special purpose. Okay, this is a huge one. Functions. Think of a function as a reusable recipe. You write the recipe down once, that's the def part. And then anytime you want to cook that dish, you just say its name. You don't rewrite the whole recipe from scratch. The ingredients you give it, like name here, are called parameters. This all comes down to a core programming idea. Don't repeat yourself. Now, the really cool thing about Python is you don't have to build everything from the ground up. Python comes with tons of modules, which are basically pre-built toolkits you can import into your code. For instance, if you need to do some serious math, you can just import the math module, and suddenly you have access to all these powerful math functions. It's like having a giant library of pre-written code just waiting for you to use it. All right, enough theory. It's time to get our hands dirty and see how all these pieces fit together to make something real. We're going to build a student grading system from scratch. This project will use everything we've talked about: variables, decisions, loops, functions, everything. Let's start building.
First things first, we need to build the brain of our operation, the grading logic. We'll wrap this up in a neat little function called compute_grade. It'll take a score, run it through our if, elif, else logic, and then return the correct letter grade. By making this a function, we create a reusable tool that we can call on for every single student.
Okay, great. We can handle one student, but what about a whole class? This is a perfect job for a for loop. We'll start by asking the user how many students there are. Then we'll loop that exact number of times, asking for each student's name and score, one by one. This is automation in action.
So, inside that loop, for each student, we'll take their score and pass it to our compute grade function to get the letter grade. Then we'll package up their name, score, and grade into a dictionary. And finally, we'll add that little package of info to our main list of students. See how we're combining data structures here? It's a great way to keep complex information organized.
And voila, here is the final result of all our code: a clean, organized report showing every student and their grade. This is what it was all for. We took input, used a function to make decisions, repeated the process with a loop, and organized everything with lists and dictionaries. Seriously, congratulations. You've just seen a complete application built from the ground up.
That was fantastic work. You've come a really long way in a very short time, from typing "Hello World" to building a whole project. So let's just take a quick moment to recap what you've learned and talk about where you can go from here.
Let's just pause and appreciate everything you've just mastered. You now understand the basic syntax of Python. You can handle data with variables and different data types. You can control your program's flow with if statements and loops. You can organize data in lists and dictionaries. And you can write clean, reusable code with functions. That is a huge accomplishment and a super solid foundation for whatever you want to build next. So, where do you go from here? Well, you can start exploring more advanced topics, like reading and writing to files, handling errors gracefully, or a really powerful idea called object-oriented programming. But honestly, the single best piece of advice I can give you is this: just start building things. Think of a simple problem you have, maybe a little calculator or to-do list, and just try to build it. That's how you really learn. I really want you to take this to heart. Programming is not a memory test. It's not about memorizing every single command. It's about looking at a problem and thinking, okay, how can I use the tools I know to solve this? It's a creative puzzle. The more you code, the better you'll get at solving those puzzles. So as we wrap this up, I want to leave you with one final question to think about. What problem will you solve first? With the skills you have now, you can actually start creating things. Your journey is just beginning. Keep coding, and I honestly can't wait to see what you build.